Hey everyone, let's talk about graphing linear systems. So before we can actually graph a linear system, we need to know what a system of linear equations is. So two or more linear equations form a system of linear equations. Normally, you'll just hear me call it a linear system. Or even a lot of times, I just say a system, okay? But the key here is that it's two or more linear equations. So, for example, if I have y equals 2x plus 8 and 4x minus 3y equals 7. Those two equations together are what form my linear system. It's not one or the other, it's the two of them together. Okay? Then we need to figure out what it means to have a solution to a linear system. So a solution of a linear system is a set of numbers a and b for which a and b make each equation a true statement. So if you remember, we actually did this in chapter 4. I gave you guys a point and I asked you if it was a solution to the linear equation. So now what we're going to do is we're going to get this point and we're going to see if it's a solution to both of our linear equations. And if it is, then it's the solution to the system. So we always write the solution as an ordered pair, which means we would go a comma b, right? We need those parentheses. And since the a is the one that comes first, that's my x, and that means that the b stands for my y value. So we're looking for this x and y value that complete the linear system. So in other words, we want to make it true. Okay? So jump down and look at those graphs really quick. We've got these two lines graphed here. I don't even know what the equations for those lines are. I don't really care. What I care about is that they're already graphed. And what I'm doing is I want to see which one point completes both of them. So I'm looking for their point of intersection, which happens to be right here. And it's even labeled for us already. So the solution to that linear system is the point 3, 2. All right? So the point that lies on the graph of each line is called the point of intersection of the graphs. Okay, the point of intersection, that's our solution. Cool. So go to the next page and let's take a look at these examples here. So for these ones, we're given the lines already, right? We are given that this is the equation for this line right here. And this equation is this line right here. So I don't have to graph them myself. I luck out and they're already graphed. Okay? What I want to do is I want to find their point of intersection. So I see that they intersect right there. That coordinate point then, I'm going 2 to the right and down 1. So that's the point 2, -1. So I'm pretty sure that that is the solution to my system, but I'm going to have to check it and make sure that it actually works in both equations. Okay? So go down to the bottom, and we're going to check that orange equation first. So 3x plus 2y equals 4. And remember, anytime I want to check a solution, I'm going to take out the x and y, and I'm going to put in some parentheses. So 3 parentheses plus 2 parentheses equals 4. And inside those parentheses, I'm going to put my x and my y. X always comes first, so that's the 2, right? That's my x. And then -1 is my y. So I'm going to put those in and see if this actually works. So 3 times 2 I get 6. 2 times -1 gives me -2. 6 minus 2 is 4. So 4 equals 4, and hey, that worked. So cool. I know for sure that the point 2, -1 is a solution to my orange equation. But that's only half my system, right? I have to check the other equation and make sure it works in that one too. So let's go over here and let's check -x plus 3y equals -5. And again, I'm going to take out the x and y and I'm going to put parentheses. So negative parentheses plus 3 parentheses equals -5. And inside my parentheses, I want to put my x and my y. So x was 2, y is -1. And now I'm going to simplify. negative 2, and then 3 times negative 1 gives me negative 3 equals negative 5. And hey, negative 2 minus 3 is negative 5. That equals negative 5. That's true. That means that the point that I found is my solution to my linear system. So the point 2, negative 1 is my answer. That's my solution. You do need to show me this work down here. And you need to write your original equation, plug in your x and y, and then start to simplify and get all the way down to the bottom. All right, you got to make sure you're showing me all these steps here. Okay? You guys are going to try number 2 on your own if you haven't done it already. And let's jump down here. Step 1 for solving a system by graphing. Well, these ones were graphed for you, right? So now we're going to jump down and we're going to figure out, okay, how do I do this from the beginning? So step 1 is going to be to make sure that both of your equations are in slope-intercept form. Make sure both equations are in slope-intercept form. Because the easiest way to graph is when we're in slope-intercept form. Okay? Once both of your equations are in slope-intercept form, you're going to graph both lines on one coordinate plane. On the same plane, because we're looking for their point of intersection, right? Which brings us to step 3. Find the point of intersection. And finally, step 4 is to check your solution in both equations. If you only check it in one, that's a problem. We have to check your solution, solution, Miss J, in both equations. Not just one of them. Okay. All right, let's try one. So let's look here. And for this, you guys, I really recommend using colors. You don't have to. I just think that it kind of helps to be able to talk about like, ooh, the orange line or the purple line or whatever. And you also need a straight edge. So either grab your ID or make sure you've got a ruler or something that you can use as a straight edge. Okay, that's going to be key in this chapter. So let's look at that first equation. Step 1 says we have to look and see if it's in slope-intercept form. Well, y plus 7 equals 2x is definitely not in slope-intercept form because I want it to be y equals mx plus b, and it's not right now, which means I need to solve for y. So I'm going to draw my wall, and I'm going to get y by itself. So subtract 7 from both sides, and when I do that, I get y equals 2x minus 7. Now that equation is in slope-intercept form, and I'd be able to graph it really easily, right? Then let's look at the second equation. X plus y equals 2. Well, that's not slope-intercept form either. So draw your wall. We want to get the y by itself, which means move the x over. So I'm going to subtract x from both sides. So y equals negative x plus 2. Now I'm in slope-intercept form for that equation too, which means I'm done with step 1. Now both of them are in slope-intercept form, so I'm good. Now I can move on to step 2, which is graph them. So let's look at that first equation again. Y equals 2x minus 7. If I want to graph that, I have to start at my y-intercept. So I usually remind myself, my m is 2 over 1. My b is negative 7. So I'm going to start at negative 7. And I'm going to use my slope to move. A positive 2 over 1 means I'm going to go up 2 and right 1. And we're going to follow that for as far as we can go on our coordinate plane. I don't want you to just do 2 dots and move on. Okay? Keep going up 2, right 1. Up 2, right 1. Up 2, right 1. Well, I went as far to the right as I can go. So instead of going up and to the right, now I'm going to go down and to the left. Oops, down 2, Miss J, and over 1. And then we're going to draw our line. So use your straight edge and draw your line in there. Make sure that when you draw your line, it goes through your points and it's nice and straight, and you've got your arrows on the ends also. Okay? So I just graphed the orange line. Now I want to see if I can graph the purple one. So I'm going to do the same thing. I'm going to figure out what's my slope and what's my intercept. So m is negative 1 over 1, and b is 2, and we always start at our b value. So I'm going to start at positive 2, and I'm going to use my slope of negative 1. So down 1 and right 1. Down 1 and right 1. Down and right. Keep going even though you see where their point of intersection is, because it's good habit and because it's good practice with finding your slopes and graphing them. All right. So draw as many dots as you can using your slope, and notice that I'm going the other direction now too, right? If I start at my y-intercept, I can go down and to the right, or I could go up and to the left and follow it through all the way. That's a lot of dots on this line, right? All right, then draw your line through. If you need to pause the video, by the way, as I'm doing these, or if you need to rewind, then you should be doing that. But you should be following along with me and doing what I'm doing, okay? If I'm moving too fast, just pause the video while you draw your graph. That's okay. All right, there's my lines, right? And we look out, we can see that point of intersection. So step 3, finding that point of intersection, we just need to see, where do the purple and the orange cross? They cross right here. So let's see what point that is. I went 3 to the right and I went down 1. That's going to be the point 3, negative 1. So I am pretty sure that that is my solution to my linear system, but I need to follow through with step 4 first. Oh, you guys can't see that. 3, negative 1. There we go. I need to follow through with step 4 and check my solution in both my equations first, okay, before I officially move on. When I check my solutions, I always go back to my original equation. All right, so 3, negative 1. So really quick, let's figure out the 3 is the x value and the negative 1 is my y value. So that's what I want to plug into my original equations here. So I always go back to my very original. So my first orange equation was y plus 7 equals 2x. So take out x and y and put in your parentheses. So y plus 7 equals 2x. And I'm going to plug in my x and y that I found from my graph. So we said the x value was 3, so put that over here. And our y value was negative 1. And let's see if this works or not. So this is negative 1 plus 7. 2 times 3 is 6. Negative 1 plus 7 is 6. So I get 6 equals 6. Awesome. It works in my orange equation. But remember, I have to check it in both. So now I need to check my purple equation. So my original purple equation was x plus y equals 2. So take out your x and y and put some parentheses. And we're going to plug in 3 and negative 1. So 3 and negative 1. Sorry, I'm kind of squeezing it in on the bottom here. But I get 3 minus 1 equals 2. I'm going to jump over here really quick and then say 3 minus 1 is 2. So I get 2 equals 2. There's my check mark. Again, please make sure that when you're checking your solution, you write your original equation, then plug it in, start to simplify, and then show me your final step. Show me that it's actually true. This chapter is kind of nice, you guys, because you can check all of your solutions here. You should get 100% on this test then. As long as you're following the steps and you're going through and checking, you should know whether you got the question right or wrong. Okay? So there are more examples for you to go through in your packet. You can definitely try number 2, which I think is probably the easier one because they're already graphed for you. And then you can go ahead and jump to the next page and start working on the next question. All right? I will talk to you guys later. Bye.